In this video, I want to define radian measure. Let's begin with a picture. Let's take a radius, or array rather, of length r. We rotate it some angle theta. When we do that, the end point of the ray draws out an arc, and that arc lies on a circle of radius r. Arc length typically denoted with an S. So we are going to define the radian measure to be arc length divided by the radius. For with these particular symbols, our angle in radians, theta, is S over R. An equivalent definition, we can say that the radian measure times the radius is equal to the arc length, or theta times r is equal to S. Depending on what problem we are working, we may want to work with this formulation or this formulation, okay? But they are equivalent. So, let's look at two examples. First, I'd like to calculate the radian measure of a complete revolution, or 360 degrees. In this case, my arc is the entire circle. Okay. So its length is the circumference. So the radian measure is the circumference of the circle, which is 2 pi times the radius, divided by the radius, which here is equal to r. Regardless of my radius length, the r's are going to cancel, and I'm left with 2 pi. So 360 degrees is equivalent to 2 pi radians. One more example. Take a ray of length r, rotate it 1 radian. What is the arc length going to be? Well, now we look at the second formulation for the definition. We know that 1 radian times the radius is going to give us the arc length. So in other words, the radius is equal to the arc length. So this is a way that we can define what 1 radian means. 1 radian is the rotation needed for the arc length to equal the length of the radius.